Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, I'm going back to, well, my comfort zone, and we're going to be working on some Commodore 64s. I was recently at VCF Pacific Northwest up in Seattle, and some very nice viewers gave me some parts machines, unknown condition C64s. I actually have 4 of these, haven't even tested them, so on today's video, we're gonna take a look at these and see if I can get them working. Maybe they work, maybe they don't work, maybe they have easy problems to fix, maybe they have hard problems to fix. It's gonna be a total mystery grab bag of C64 repairs. Some of them might be easy, some might be hard. It's really hard to know because I haven't even turned these on. So without further ado, let's get right to it. As is usual with these types of repairs, I always like to first test out that my bench power supply and my video capture setup is working properly. You don't want to go chasing your tail trying to fix a computer that you think has like a black screen when it turns out that you actually have a problem with your capture setup, or if you're not using a capture setup like this, your display setup. I'm using a RetroTink for video capture, and as you can see, it's working just fine. This machine, of course, everyone has seen many times before. It's my ZIF64, so it's got some ZIF sockets on it. It has a 1ROM from Piers Rocks in here, so one of the older ones with an STM micro controller as opposed to the newer Raspberry Pi based ones. As a replacement RF modulator that's kind of all hacked together. We have a VIC-2 Coari, which is a FPGA-based VIC-2 replacement. This version only supports analog output, just like the original VIC-2, but what I like about it is it actually supports switching between PAL and NTSC on the fly, which is something you cannot do normally without changing out the crystal oscillator and the VIC-2 chip. We have a SIDKick for the SID replacement. This is a Pi Pico based project, open source, and it has a DAC on there, so the audio output quality is really good. It does support multiple SIDs and stuff like that, although that's not wired up. You have to wire up some extra pins there. And then we also have a replacement PLA. This is a Soviet Union era SIGNETIX 82S100 clone type chip that's been programmed with the Commodore 64 PLA code, and it's nice and cool. It runs super cool, so that's awesome. It's amazing this 64 board has never failed. It was broken when I found it. It looks like I worked on it back in March of 2019. I think I'm not sure if that's when I added the ZIF sockets, but it was somewhere around there, and I have abused the heck out of this board, and it just still manages to work. And the ZIF sockets, of course, make it just easy for me to test out PLAs and the CPUs and the various chips and stuff like that. And yeah, I kind of use it as a test bed for just whatever I need to do with it. And yeah, anyways, it just works. And yeah, of course, it's in a VIC-20 case, which is why it's this color. And we have the Euro style keyboard, which I like. So the whole thing is just a hodgepodge, but we saw that it was working. So now let's grab the first machine we're going to look at. All right, here it is, and the machine is in dirty shape, but otherwise actually is screwed together, so who knows, this thing might actually work. Luckily, I have a bag full of replacement stems and keys, so hopefully I have the missing 8 key to kind of turn this back into a complete machine after it's cleaned, obviously. Looking inside, we can see that it has a metal RF shield on it. That tells us that this is going to be one of the later motherboards, the very last revision for the long boards that would be in here, the bread bins that is. And we can see, I think this is a made in the USA machine, late serial number. And one giveaway that this is a very late machine, you see these little divots here. This is where the screws would screw into the bottom cover, and they've added a little extra plastic so it doesn't poke through. But this has little divots here in this position, and the reason why is that is designed to hold the shortboard version of the 64 motherboard, the ones that came in the 64Cs. So it's really only in the very later versions of these bread bin cases, at least in North America here, where you see these little divots here that can accept either the shortboard or the longboard. And taking these screws out, there's a little bit of a tick, and so I don't think anyone's necessarily ever been in this machine, and I have a feeling this thing might just actually work. And the reason why I say that is because these later boards are extremely reliable. It's going to be very similar to the board that was in the Field Found 64. Oh, I hear that crack. Yeah, that's exactly like I thought. We have a dust bunny there. And you can just tell this thing has, well, I don't think it's ever been really touched. This is really the dust and stuff from the keyboard cable that was sort of lying on top of the shield. Probably this got dropped because these were sort of all over to one side. And there are two versions of this motherboard. We'll see what this is in a second. There's one version of this long board that has 8 RAM chips, and there's another version that only has 2 RAM chips. And this one, well, we'll find out which one this is in just a moment once I get these fasteners off. All right, here we go. That's the 8 RAM chip version. Okay. Now notice the dust here looks like it's kind of weird looking. I think that's because the oil that was in the thermal compound that they applied to these chips has sort of, well, it's got mixed in with the dust. But looking at this thing, yeah, it's in pretty nice shape. It's going to be an R8, so the last version of the VIC-2. These chips here, the 7701, there's an 8801 version that's on the short boards. These can go bad, but there are replacements for those. I'm noticing that everything is in sockets. That's easy for troubleshooting purposes. I mean, not everything, but all the large chips, that is. We do see some issues though. So these TTL logic chips, these are the MOS versions of them, and they are notoriously crappy. Fujitsu RAM, so we don't have the same problem with MT RAM being bad. There's another one of these MOS logic chips, which kind of suck. This is kind of weird and funny. This diode is just there, like it's I think that was just like that at manufacturing. I'm trying to make sense of what we're looking at here. Like I think this was, I'm not sure actually. Yeah, see, these were kind of bodged in. I think this was like done by hand later, and this one was sort of very badly attached there, unless it was supposed to be attached just like this one between there and there. I mean, I guess that's possible, but it never was properly attached, obviously. So that's kind of funny. Like I said, I don't think anyone's ever been in here. This thing seems completely intact. Yeah, incidentally, by the way, if you notice, compared to the other Commodore 64, we were just looking at my my ZIF one, the PLA is up here on that motherboard, and they did change around the PLA and the SID chip on this later version. Okay, before I power this thing up, I don't know if anyone's powered this thing up recently or what. I think this was from a rescue, this machine, and then it was just given to me. I'm going to pop out the VIC-2 and the SID chip because these are the two valuable chips in here. And they are driven on this motherboard design by 5 volts, but also 12 volts. And there's a problem with the 12 volt regulator, then that can damage both of these chips. So I want to get these out of here. That way, in case there's a problem, then, well, I'll check the voltages first. Okay, multimeter at the ready. Turn this on. I guess, well, we'll find out if the power switch is working. Okay, 25 volts, 12 volts. So 12 volt rail looking good. This regulator is 12 volts in, 5 volts out. So that looks excellent. And we'll just take 5 volts off this chip here, just a random chip. And I mean, it's a little bit low, but sometimes you just exercise the power switch anymore, which incidentally works perfectly. It's not even gummed up a little bit. If you're having low voltage on your 5 volt rail, it could be that the connector from your power supply is dirty. But if we go right on the switch itself, looks like we're actually getting 4.8 something volts anyways. And that's the input. So input and output is the same. So it could be that you need a little bit of deoxit inside the DIN connector, or your power supply itself might not be giving, you know, a very good 5 volts. But I have my own home built power supply here that is using a switch mode power supply for the 5 volt rail. In fact, there we go. When I turn off the computer, we're at 5.2 volts. And I think we might actually have a problem with the power switch. I think we identified our first issue right off the bat because there was 5.2 volts coming in. Oh, now it's at 5.9, but a second ago, I'm telling you, a second ago, we did not have any voltage coming in. Yeah, it's working now. So let's see, is the voltage a little bit higher as well? Yeah, see, it's at 4.95 now. A moment ago, I had 5 volts on the input pin, which is the one that's closest to the body. It's this one right here. This is the one that's always on, no matter what the position of the switch is. And when the switch is in the off position, see this middle pin doesn't have anything on it. And when I turned it on, I had like 0.1 volts, but now it's actually working. So I think that switch is a little bit crusty on the inside. So probably what I'll do, I mean, you could try to take it up and open it up, but I'm just gonna try to squish some deoxit inside of that switch body somehow. What would be the best way? Maybe like down through this little crack here. Oh, I don't know if this is actually gonna help at all, but we're gonna try anyways. You can take these apart, or you can just get a replacement, or you can just move it a bunch of times. That usually does the trick. And in fact, we'll just put some into the DIN connector as well. Now, let's just check that one more time real quick. So we'll go to the pin closest to the body, 5.2, that's on the input. The output has nothing right now, turn it into the on position. 4.97, which is definitely better than that 4.8 we were having. It would have worked fine before too, but yeah, there we go. Now we're getting the correct voltage. The other half of the switch is what's handling the AC input, which goes through a bridge rectifier, then these caps, then it goes through this fuse, and this is what powers these two regulators. And like we said, these were already looking good, 12 volts, and this is for 5 volts. This one, if I recall, I think it powers the 5 volts for both of these chips as well, and the 12 volts also does the, or not the PLA, but it does the VIC and it does the VIC2 chip. Okay, power-wise, we're looking good. So we can reinstall the VIC2 chip and the SID chip. I'm kind of half expecting that this machine is just going to work. It's just dirty, it needs to clean, and with a little bit of deoxit in there. All right, here we go. Nothing. That's interesting. Just making sure the VIC is in the right orientation. It is. Yep, all these chips are in correctly. So when you have no video at all, there's a couple possibilities. This little chip here that's next to the VIC2 is bad because this is what takes the clock, the oscillator clock, and then divides it down. It generates the clock that goes into the VIC2, and then the VIC2 is what generates the CPU clock and stuff like that. But without a good clock in the VIC2, we're not going to have any video output. Or there is video output, but we have a break in the motherboard, which is kind of unlikely. There's no corrosion here. Maybe we have a failure inside of the RF modulator, or like a bad connector here, this DIN, or some type of physical connection problem. But yeah, there's just nothing happening. So we're gonna have to probe around with the oscilloscope a little bit to see exactly what's wrong. Now this thing could totally do all we need for diagnosing a 64, but just for ease of this video, I'm gonna be using my National Instruments virtual bench. Just allows me to video capture the oscilloscope. Now I've said this a million times, but I'm gonna say it again. For a computer, you need, well, 3 things to even hope to work. You need power, you need clock, and then you need a reset circuit. So if you don't have power, clearly, we're not going to get anywhere. But I already validated we have good power. So we have the 5 volt rail, and we have the other 5 volt rail, and we have 12 volt rail. That's what's needed on a 64. My hunch here is that we're missing the clock. Now, when you have analog video output circuitry, or really any video output circuitry, you do need a working clock for it to generate horizontal and vertical sync and stuff like that. On a Commodore 64, if you have a working clock and good voltages, but say the CPU is missing altogether, on this machine, you will still get a video signal. It will just be a black screen, but you will get a video signal. Of course, certain other machines, that might not be the case because the video hardware might need to be initialized by the CPU via ROM code. That would be like the later Commodore PETs, for instance. Same goes for an IBM PC, like with a CGA or MDA card, something like that, or even VGA card. Without the initialization from the CPU, you're not going to have any video outputs. You can't really go off that for sure. But on a 64 like this, the VIC2 is always generating video as long as it has power and it has a clock signal that's appropriate. If the clock is the wrong frequency, well, then you're not going to have a video signal that it can lock onto, and it will look, when you have a capture device like this, like you're getting no output. That's where having an oscilloscope will really help you because we can validate the clock is good, but we can also check the video output pins on the VIC2 chip, on the graphics chip, and just see if we have a video signal that's there. And maybe it's so far out of spec that my capture device just shows a blue screen, like there's no signal. Yeah, that's the problem with these digital capture devices like this is a signal doesn't like, it's just going to show up as no signal. Even though there is a signal, it's just incorrect. All right, so we are ready for some testing here. Let's set this to auto mode, and let's just make sure everything looks good. We don't need channel 2 right now. I have it on pin 40, which is VCC, so that should be 5 volts. And you can look right here, maximum is 4.97, so that is looking good. Now pin 22 looks like it's the clock input. That's right here. Let's turn it on. Oh, we do have something, but that doesn't look right. It should be a higher waveform than this. I think what I'm going to do is I'm going to take out the VIC2 chip because the fact that there was a bit of a signal there, and I'm looking for my chip lifter, here it is. The fact that there was a little bit of a signal there implies that this little clock driver chip was trying to drive the clock and it wasn't able to. So let's get this out. I can't remember what the clock signal should be, but yeah, it's something like 14 megahertz or something like that. Okay, so with the VIC2 out of there, we're going to be on pin 22. Oh no, same thing. Oh wait, hold on a second. No, there it is. Oh, whoops. Okay. So I made a mistake there. Clock 22, even though it says phase in, I think that's coming from the CPU maybe, and it's pin 21 that is the irrelevant clock signal. So let's try to get this to trigger properly. What's happening here? Oh yeah, okay, so we want to trigger on just the rising or falling. I like to trigger on the falling usually. So let's just do that, and this should tell us our clock signal. Yeah, 14.3. Okay, well that's good. That tells us we have a good clock signal. That's coming from this little chip here. I think it's pin 17, which isn't hooked up to anything. This is going to be the clock output that goes to the CPU. So let's just double check everything looks good on this VIC-2 chip. It does. So we'll put this back in the board here, and let's check pin 17 when I turn on the computer. Well, there's nothing. Let's check that clock input. Well, that's still looking good. So is the VIC chip bad? That sucks. If that's the case, it's an expensive and valuable chip. So yeah, 17 doesn't really have anything going on, but if we go to pin 22, that's the phase in and clock in. I mean, there's a little bit of something there, but I think that's just being picked up from this signal. That's the signal that's coming from the little clock generator IC. Now, just to demonstrate, if I pull out this little clock generator chip, I think that clock on pin 21 will disappear. So that's out. Now we take a look at pin, yep, there it is. 21 has nothing on it. So that's because it is coming from this little chip. Now this leads me to believe, unfortunately, that this VIC-2 chip is actually bad, and that's kind of upsetting. They don't go bad too often. I'm going to look at pin 15 here. This is the Luma output, so this would have a video signal if the chip were working. And if we zoom out, I mean, clearly it's not doing anything. It's just sitting there at a fixed voltage. That would be why we have no video signal. So I think this chip is, unfortunately, bad. Now what I'm going to do real quick before I go and swap this, and I'm pretty sure this is just going to be problematic. And these chips, by the way, they get pretty warm. I think I'm just going to quickly feel around. This is Feel-O-Vision. The thing is on right now. Let's see if any other chips are super hot. I mean, I'm doing this out of order. Really, I should be focusing on the video problem that we have on this machine. These chips, the VIC-2, by the way, with my right hand, they do get warm. Everything is cold. But part of it is because the computer's not running. This side of the computer is totally dead. This is getting warm, but that's normal. Without a clock signal going to the CPU, the whole, like this side of the machine, everything over here is not doing anything whatsoever. I think our VIC-2 though, no bueno. So machine's off, 65, 67, R8. These are good chips normally, and like I said, they're pretty reliable, and there is no corrosion or anything on here that looks bad. Okay, I went into my box of chips, and I found some that I think were donated by a viewer, so we'll test with this kind of older 65, 67. These ceramic ones, this is not the R8, this is a R56. I don't really like these that much. They don't produce very nice output, so if this got damaged, I mean, I don't want to damage any VIC-2 chip, but that would not be the end of the world. These early chips have color fringing on the text, but the other thing about them is they also are missing some of the Luma levels. So the various brightnesses that you can get on a 64, you don't get as many on this one as you do on the later chips. It's not really that big a deal and still totally works, but yeah, I just don't like them as much. R8s are better. Okay, here we go. We are going to go to pin 17. Oh, what the heck was that? That was weird. Let's check the clock input. That looks good. Let's check this other clock pin. Wait a second. What's going on with this thing? That's pin 17, which shouldn't do what we just saw. I'm going to check pin 15 here. Yeah, no video output at all. What's going on here? Am I missing something? Let's take the CPU out, just in case something is terribly catastrophic wrong with the CPU. Now it's easy because these are all in sockets. Normally this stuff would be soldered, so you wouldn't be able to just remove stuff quite so easily. But if we take a look again at pin 17 and we turn this on, well, we don't, oh, what the heck is going on? So this all looks exactly the same. So this is that we're on pin 22, same as what we were having before. And then here's the master clock. That looks good. That's pin 21. I'm super confused. Well, that's good in a way, because I guess this original VIC that I took out of here is probably not bad. So really, maybe it's the 7701 that's our problem. I'm gonna need to look at the schematics to see how this works. I'm not sure I've ever had a machine with a bad one of these, or if I did, I didn't look in to see what exactly was wrong with it. All right, did a quick Google for this part number here, 25425, took me to this page here. Of course, you can find the schematics all over the place. So these are all the various chips. So 8701 U31, that's the same as this chip right down here. This is 7701, same interchangeable part number. Out of this, let's see what comes out of this. Oh, this does generate the CPU clock. I didn't realize. Yeah, see right here, pin 22, that was that signal that I was looking at that didn't seem correct. The other output on this chip is obviously pin 8 here, and this goes into, what is it, a 14 megahertz input on pin 21. Yes, there it is. Oh, well, this chip is bad then. The dot clock goes into that clock 1 input, or phase 1 input, and it goes down to a dot clock signal, and it's at the cartridge connector. Yeah, cartridge expansion. Okay. All right, well, there we go. So I was misled briefly that the VIC-2 was the problem, when the reality was, just make sure this thing is off, it is, that it's actually the 7701. And those are flaky, those chips. They are known to be flaky. Now, there are replacements you can get that are not, you know, an MOS part. I'm pretty sure I have some MOS parts, so I'm gonna use one of those. But we know that this VIC is probably good. We don't know for sure, but I can be confident in saying that this is good, because we definitely did not see an input on pin 21. Which, when we take a look at the schematic here, this is for the PAL machine, so the frequencies are off a little bit. 7.88 megahertz, so we can assume it's, you know, something like that on the NTSC machine, and that should be what's going into pin 22. Without a doubt, the output of pin 17 is the clock output right there. Phase out, that's the CPU clock. And if we follow 17, it goes to phase 0, but yeah, 0.98 megahertz on the PAL machines, and it's like a little bit faster on the NTSC machines. That is what goes to the CPU. Okay, well, I need to go back in my bin of parts and find another 8701 or 7701 to replace this bad one. So this gets the X of shame, and out it comes, because it is bad. All right, I found some replacements. So these 8701s, I think I got these off eBay or maybe from AliExpress a while back, and they were very inexpensive. I have no idea if you can still get these. I'm pretty sure these are not fake parts. I think these are just the replacement parts that MOS had made and sold on the market. We have a ceramic miniature one as well from 1985. You can see these have 87 day codes. I know that these are 2 replacement modules. Let's see if these have any markings on them as to like who made them. Doesn't really say, but I can't really tell exactly what kind of part that is. And then this one here has a same ICS chip. Oh, it's actually exactly the same part that's on there. That marking is 525-01R. Obviously, MOS 8701, that's the chip we're going to be replacing, but I don't know if those other part numbers mean anything, like who created this or whatnot, but I think any of these should work. Probably what I'm going to do is I'll just, I don't know, let's stick this ceramic one on there. And hopefully that is all we need to do. And I accidentally noticed I just put the CPU back in the VIC-2 socket. So, yep. Hopefully I hadn't turned on the computer with it in there. I don't remember if I did, because that would have damaged the CPU. It has 12 volts on one of the pins on this socket. That would be bad. So, in with the VIC-2. And let's take a look at pin 22, the input that had failed on this chip, the output from here going into this. And let's see if we have a good signal now. All right, here we go. 3, 2, 1. There we go. That looks good. The jitter and stuff, that's totally normal. And unfortunately, the frequency counter on this oscilloscope is terrible. And of course, this is the clock input. That looks right. And we have pin 17, which is the clock output. And I have to zoom out a little bit. There we go, 1.023 megahertz or so. That is working now as well for NTSC. And now if we look at pin 15, that's the sync plus Luma output. We can see if there's a video signal or not, and there totally is. And we can tell right away, this machine is freaking working. So if you're looking at the video output of C64 on something like a scan converter, you will see on the far left side a white line. Even if you have a black screen, you have a white line. What you can see here is we have the white line, then you have the border region, then you have the darker background, it's dark blue on the 64, then another border, and then we have the horizontal sync pulse. Well, what you see here is occasionally this goes up because that's the border going across the entire screen. And the other time you can notice there's like little jaggedy lines in there. I was trying to capture it with a single shot. and I'm not having any luck. But that's text. That is literally the basic screen text that's printed there. And sometimes you'll see it just right a little bit over here on the side. That's the ready prompt. Otherwise, it's the Commodore banner that's on the top of the screen. So that was the ready prompt, and that's the stuff. So this machine, I'm positive, is actually showing us a basic screen with the banner. So we're at that point. We don't know if the whole thing is actually working, but without a doubt, our 7701 had failed and kept this computer from working. So now if I switch to the video input of the machine, it is plugged in right now. Dust bunny. We should have the normal screen. Yep, there it is, looking good. And wow, it's really jailbar free as well. Now we're just on composite video and it's kind of soft, and that's because this RF modulator would need a little bit of a mod. There's a video on my channel to show you like what to cut out inside of this to really sharpen up the video. But yeah, awesome. Now what I'm going to do is I'm going to pop in the Des Test switch cartridge. This is going to do a full comprehensive RAM test on this machine. Generally, it was at the basic prompt there. RAM is probably fine, but Des Test switch is going to do a nice thorough March RAM test on the entire memory space of this machine, just so we validate the RAM is completely solid. And it's cool that all of this MOS TTL logic on here is fine, as is the PLA and the SID there. And now that I'm looking at this again, yeah, I think that output was just dead on the clock output, the dot clock output that we were looking for. I've never really studied what the typical failure mode of these chips are, but I guess that's probably it. Like one or both of the clocks just is dead, and then that keeps the VIC from working and generating the clock for the CPU. What's unfortunate is the old clock circuit on the 64 was fine. It was just TTL logic, and it was highly reliable. It just had more components, and MOS made this chip to simplify things, and well, they made the computer more unreliable. All right, so this has switched into, yep, full RAM test mode now. So the initial phase only tests like the first 4K of memory, and then it switches modes. That's what the switch means. And yep, it's testing all 64K. I'm just looking at the bottom. Time of day down here. Those times are the same, except AM and PM, that's correct. So that's telling us that these two VIA chips, or CIAs, or whatever they are, 6526s, they are likely good. It doesn't tell us that all the inputs are good, but like the chips themselves are alive. I think the basic character ROM and kernel are fine, because obviously it was in basic. Without those working, we wouldn't actually be getting into basic. You could take these out though for this ROM to run. This will run without it. I should probably update this ROM, version 0B, 25th of November 2024. The RAM test takes a little bit of time, so I'm just going to let this sit, and then after this finishes, I'm going to grab the test harness and we'll plug that in. I just need to clean up these edge connectors a little bit. They're looking a little dusty. So I'll do another full harness test just to make sure this thing works, and the SID chip's in there so we can hear if the sound is working and stuff like that. All right, there we go. The RAM test takes quite a while when you're doing the full March testing, but it totally freaking worked. Awesome. Now with this diagnostic test harness, this just sort of automates the testing of everything on the 64. You don't need to use one of these. If you don't have one, it's no big deal. Just put the computer through its paces, play some games, use both controller ports, type on the keyboard, use the floppy drive, you use the tape port. You just kind of have to use all the peripherals. Now, if you never intend to use the tape port and the tape port does have a fault, like, oh well, not the end of the world. If you're not going to use the tape port, who cares, right? That tape port's not working properly. But using the harness just sort of simplifies all that testing, and then we just have to use the regular diagnostic mode. This is a double-ended cartridge. Dead test one way, and regular diagnostic the other way. I don't really recommend using dead test much anymore, because Des Test is a much better diagnostic cartridge for machines that are having problems, in my humble opinion. But we're just going to use the regular diagnostic mode here, which is what uses the harness. Oh, we got one more thing here. This is for the IEC, or the serial connector here that goes to the floppy drives. And we just turn this on, you got some LEDs, and now it's just gonna run through a similar test. It's gonna test the RAM, which is superfluous because we just tested it with a much better RAM test than this junk RAM test. And then it will test the rest of the peripherals. Oh yeah, including the sound. Looks like we're gonna be in good shape here. This really tests everything there. SID is working. I mean, we'll need to listen to some music to make sure it works perfectly, but so far, so good. This is a basic sound test here. I'm gonna pop in the Kung Fu Flash. Let's grab the keyboard. I noticed this keyboard has one broken stem. And the problem with broken stems is it can cause that key to be pushed down all the time, which may or may not cause problems in BASIC and stuff like that. So worst case, if you have that problem, just take the keyboard apart and remove that key stem altogether, and you'll just be missing that key. And what you can do is, because an A key is more important than, say, like the pound symbol, like just switch that over there, and that's better until you get a replacement key, that is. And I think what's happening here is this 8 key is being held down, so I need to kind of lift up on it. And let's see if the keyboard is working otherwise. Yeah, I think the keyboard is working as long as that key is not held down. So we have a keyboard tester here. So I'm holding the 8 key plunger up. And yeah, see, things, so I was going to push 8. I'm like, oh, it's not working. Keyboard's filthy, but it is actually working. There we go. And if I let go of the 8 plunger, yep, there we go. It's held down now. So this is actually a fully working keyboard. It's just really dirty, but the whole computer's in decent shape, to be honest, other than the broken key, which I can get a replacement for. And then dirt just needs to be, get a good scrubbing. Nice. And just for ease of further testing, I'm going to switch over to my ZIF keyboard here, just because I don't feel like that holding up that whole 8 key thing. Because what I'm going to do is I'm going to run the dance party to make sure that this SID is working. Push the space bar for a little action there. Sounds good. Sounds freaking good. Yeah, it's good. This is a good SID. All right, all right. By the way, one thing I want to mention is I really don't like these round donuts here. You can get these off. You just kind of have to squish the cable through there, or you can use a hammer just to hit it and it will break it. I don't like these just because it kind of bangs around inside the computer, so I'm actually going to take it off of this. So I'll do it without breaking it. And that way, if you want to reinstall it at some time in the future, you can do that. But you just kind of shove that through, and there we go. That just is less annoying than this thing floating around inside there. Often there's one on this cord as well. I don't think I mind this one as much because it doesn't bang around, because once the LED is plugged in the motherboard, it sort of stays up. These are just interference suppression things. Okay, there's our first Commodore 64. What have we learned? Well, we learned that, you know, they had good power. We had no clock, and it turned out to be the 7701 chip. And once I figured out that both the dot clock and the color clock, I think it's called. The color clock was good, the dot clock was bad, and without the dot clock, you're not going to get any kind of clock going into the CPU. I kind of assume that the VIC needs both of those to generate the CPU clock. I'm actually not sure what happens if, like, say the 14 megahertz clock were gone, but the 7 megahertz one were there. Would it then generate the CPU? We'd have no video? Not totally sure. But the telltale sign there was something wrong with the clock was the fact that there was no video output whatsoever. And I never really need to invest in anything further than that, than just kind of go right to the clocks, because that one symptom is what told us pretty much what we needed to know, that we either had a bad clock or we had a broken connection between the VIC and the connector, or, I mean, I guess the VIC could have been bad itself. If we had both good clocks and no video output, then the VIC would be bad. Less likely, less common, that is. And if we had an Luma signal coming out of the VIC, but we didn't have it out of here, that told us the broken connection, or maybe the RF modulator, because the RF modulator does take the video signal, process it a little bit, amplify it and stuff like that. And if you have a bad transistor in there, that could cause a problem as well. And then, of course, I think what the last thing was, if the clock were off, like it weren't running at the right speed, then you might get a video signal out of the machine that was not good enough for the scan device to, like, recognize it as PAL or NTSC, and in that case, you would get nothing. So there we go. First machine is up and running. Let's grab another one and keep going, fix it. All right, this one is in, well, complete shape. It's dusty, but obviously it just needs a bit of a clean. And it's got the beige function keys. That really means nothing. What else is there to say about the top? Nothing really, just needs a clean. Bottom does not have those little dimples, so this is an older machine, as I was mentioning before. Those dimples are a giveaway unless someone's like swapped the covers around. Made in USA, serial number is lower than the other one. We can take a gander inside here. I can see it's got the cardboard RF shield, so that's another indicator that's the early one. Always those later motherboards, like the one that we just worked on with that metal shield, that's the telltale sign that it's a later machine, like getting far on in the bread bin's life cycle. That made a tick sound, so I don't know if anyone's ever been inside this. This machine's in very nice shape, I must say. But the fact is, yeah, that cracked as well. The fact that it's the cardboard shield means it's the less reliable of the 64s. I'd say the bread bin era, like in the middle here, not the really old ones, like gold labels or those first generation with the 5-pin video, and not the very end, like the one we just worked on. These middle ones, these are the most unreliable. And it's mainly because they got empty RAM a lot of times. They have those terrible PLA chips, you know, all that kind of stuff. So we'll see what we got going on inside here. It's weird. This thing is, there we go. Oh yeah, it was all sort of stuck together. Yeah, you're gonna get some crack noises out of these when you take them apart. Here we go, listen. That's just normal. But there we go. This is in really clean shape. I'll just get rid of that little copper tape there. This obviously is the older board. Wow, 2 of these chips are in sockets. Strange. And then we have the kernel ROM in a socket as well. Plus, that's sort of made by a company. Well, yeah, I guess I've seen this. It's an O2 kernel. I didn't even check the other one. I'm sure the other one was an O3 kernel. And as I mentioned at the beginning of that other video, you see the SID is down here and the PLA is there. They're swapped. This is the same way it is on the motherboard, on my ZIF 64 board. That's the opposite of what we were just looking at. Yep, this just keeps the heat in, and I'm getting rid of that immediately. Let's pop this open and see what we have inside the Vic canister. I've learned from Mark over the Retro channel that inside here are some caps that can leak, these guys. I've never run into it, but Mark has had that a few times. Maybe there was something to do with the manufacturing in Europe. I think that's where the 64s in Australia that he gets his hands on come from. Maybe they use bad caps, but I've never run into that here in North America, and I've worked on a lot of 64s. But anyways, it's these twos, and they can leak and then cause all sorts of corrosion on the board and clock issues and stuff like that. Let's clean that off and just see what kind of VIC we have, and I'm pretty sure that's going to be obviously an R8. 14 megahertz is definitely an NTSC console, or computer that is. And yep, 6567 R8 is what we got there. And that thermal compound got all over the pins of the chip. That just sort of happens. It's not a big deal. It's not conductive. You can try to kind of clean it off with a cotton bud there like this. All right, so what do we see again? So we have our O2 kernel. That is in a socket, so that's kind of nice. Although these chips can go bad as well. Things dusty inside, but actually really clean. The dust is just right in this one area. Everything over here is looking fantastic, to be honest. 7406 here is in a socket, and I don't even recognize that brand. Who makes this? It's like a B symbol, like beta. Interesting. And then these 2 TI chips are also in sockets, the 74LS257s. We don't have any MOS logic. We have Mitsubishi RAM, and all of the RAM chips are the same. You can have mismatched RAM. That is something that Commodore did. They just sort of pulled from whatever they had on their table, I guess, when they were building machines. This one happens to have all the same memory. Of course, the usual like hodgepodge of suppliers and manufacturers. The SID's from 1983, PLA, which is also soldered, by the way, is from 1983, and these are the most unreliable of them, in my opinion. And yes, machine definitely seems to be from the end of 1983. That's when it was put together, which coincides with this type of board. It's the 250-407. It's written right there. And really not much else to say about this. I'm just going to straighten this out because it kind of bugs me that it was off to the side. Because the SID chip is soldered in the board, I can't remove it, but I can remove the VIC-2 chip. Now, it is hard with these metal shields to get these out, so what you can do is use a O-ring pick like this. Just make sure you don't disturb any of the nearby components, and you can pick the chip out of the socket like that. So these are very useful for getting them out. You can get these at like Harbor Freight here in the US or any other like cheap tool place. I get a set of 4, and this bendy one is my favorite. Okay, so this chip is out in case 12-volt regulator is bad. The SID will be sacrificed, but not much we can do about that. All we can do is exercise the power switch a little bit, and we're going to go through the same exact thing we just did a moment ago. So let me grab the multimeter. We don't have to worry about the 7701 or the 8701 being bad, because of course we have discrete TTL logic, and it is so much more reliable. And we'll check the output of these 2 regulators, 4.9, 12.001, perfect. That's looking great. And I got to cross over my hands here to check the 5-volt rail, which we had issues with on the other one because of that dodgy power switch. Yep, looks like we have the same exact problem. You see that? 0.37 volt. All right, so I've clipped onto some capacitors here just so we can keep our eye on the 5-volt rail. And let me just jiggle around what we have over here. See if I can figure out what's going on. So weird. Where's our issue? It's not the fuse. The fuse is only for these 2 regulators. It does not handle the 5-volt rail over on the logic. That comes directly from the power supply. Oh. Okay. So we pull up on it and it's good and it goes down. Is this just a bad connection or is it a broken solder joint? It could be either. So let's pop some deoxit into the pins there. And we'll just push this in and out a few times. Let's see if that makes a difference. Well, look at that. It's like magic. Deoxit that connector instead of socket. So, yeah. Well, all right, problem solved. The other one, it was the power switch, I think. And this one, it seems to be the DIN. You can see that kind of still is not great. So let's put it in and out a few times. They just get dirty inside. That's what happens. These pins too, I suppose, could be a little oxidized. This cable itself came from a real power supply, a Commodore one, and I cut it off and built my own power supply at the end of the cable. But let's see if that looks better now. Okay, better. There we go. That's what you expect to see. All right, so we validated that the 5 volt for the logic is good. We know that these regulators are good. That means I can put the VIC-2 chip back into the socket, and then we can check to see if this thing is working. And I guess at this point, we'll just go right to a video connection, and we'll see if it's producing video. Okay, here we go. 3, 2, 1. Black screen. So we have good clocks. Yep, black screen. Full black screen. Okay. Well, right off the bat, I know if we use the oscilloscope, we'd be getting a good video signal. We didn't see the white line on the side just because of the way the capture device is set up, but it would be there. So I have a feeling we're fine with this, but the machine is not working. Okay. So what do you do when you run into a situation like this? Well, we could have all sorts of issues. We could have bad RAM. We could have bad ROMs. We could have a bad CPU. You could have bad kind of anything. But with this machine, the first thing you should suspect is the PLA. Now, it's not in a socket. I can't just swap it out. That's kind of lazy anyways. Well, let's try and figure out what exactly is wrong. I could put the dead test switch in there, or dead test, but let's just see if we can find the issue without even trying any cartridges, because say you have a 64 that's dead and you don't have any cartridges and all you have is something like this. Let's just quickly talk about how a 64 works. When you first power it on, what happens is you get power to all the logic, and the clock signal, which we know is good, is going to the CPU, and the CPU should come out of reset. So we'll have to check the reset line if that's fine. So once it comes out of reset, there's a reset vector. It starts to execute code from the ROM chip. And what that does, it starts, loading stuff off ROMs and talking to RAM and, initializing the whole computer. Well, the thing is, the thing that selects the ROM to say, hey, the CPU is trying to talk to the ROM, turn on and respond on the bus, that's the PLA chip. If the PLA is, say, broken, it might not tell the ROM to turn on, or maybe it's telling the ROM to turn on at the same time as one of the other chips, and then you get a bus conflict, and that keeps the system from working. Well, that's what happens often when these PLAs, especially this particular vintage, when it goes bad, it's often selecting and turning on multiple things at the same time, causing that bus conflict. All right, so we're gonna look at the schematics, and I searched for 25407, which is this schematic here. It says right here, 25407, it's a different revision, and 251138, matches for the most part. This is a 251-137, but close enough. So let's look at these combined ones. This is a slightly different motherboard design than the previous one we looked at. What's kind of annoying about this particular scan is it's extremely hard to read. This is a PLA chip here, and it's just photocopied of the 50th generation. So I'm just gonna see if I can find a better quality scan. Is this one more readable? This one looks more readable. It's kind of the same thing. It's just, they're all similar enough. Oh, it's kind of hard to read as well. Now, let's have to make do with this scan. Let's see if we can find the reset line. It should be around here somewhere. Non-maskable interrupt. I can never remember which is the reset pin. There it is. Pin 40 on the CPU. That is reset. All right, so when I turn on the computer, it should stay low and then go high. Okay, reset is good. That took about, I don't know, a second or so, and it came out of reset. Perfect. So the reset circuit's working perfectly, and that's exactly what I needed to know, because we just eliminated that as a potential problem. Let's just check the clock real quick. So this is at pin 17 on the VIC-2. We were looking at the other one. There it is, 1.02 megahertz. So our clock is good, our reset is good, and our power is good. So our problem with this machine totally is somewhere else, and I have the hunch it's right here as the PLA. So the PLA has a bunch of inputs. That's the I side. See all these inputs? Input 0 through input 15, and then the F lines are the outputs. One of them is unused. That's pin 1. But the rest of this is actually used for stuff. So CAS-RAM is generating signaling for the RAM itself, basic ROM, kernel ROM, character ROM, graphics read-write, that goes to the VIC-2 chip if I recall, I/O, ROM low and high. I think that goes to the cartridge port. There is a little bit more that is doing chip select, but besides the PLA, that could be problematic, and it is this chip right here, 74LS139. If we don't see any problems on the VIC-2, it could be one of these. See, VIC, SID, and color. Those are select lines that go to the VIC chip itself, the SID chip, and the color RAM as well. So, and that goes through some other gates as well. So that's part of the chip select logic on the motherboard. We do have to look at all that. But let's start by looking at these very hard to read pin numbers. So it looks like starting with pin 10. What we're going to be expecting when I turn on the computer is that the outputs are either going to be high all the time or they're going to have little bursts of going low, but it's not going to be low all the time. And the failure mode for these types of PLAs, these 1983 ones, is that it never really goes up to 5 volts. And maybe when it's high, so not selected, the signal's like at 1 volt or 2 volts or something like that. And that can often be right on the threshold of causing chips to be on all the time. Remember that the chip select lines that are output out of these have lines over them. That means they're active low. So when the output is low, it's turning on that chip. Only one of these should be low at any given time. There should never be a time when you have 2 of them low at the same time. So that's what we're going to be looking for starting on pin 10, ROM H. Now, I can look at this pin, but it's not actually going to anything because this is hooked up to the cartridge port and there's nothing plugged into it right now, but we'll start there anyways just for thoroughness. Okay, so this looks fine. We're at like 4.3 volts. It's TTL logic, so that's completely okay. Next one, I'm on pin 11, looks fine as well. Here's the IO line, that looks good. We have 3.94 volts, that's fine as well. What is that pin? I'm on pin 13, I think. GRW. Pin 14 is ground, and then pin 15. There's pin 15 right there. I'm noticing there's like no activity. Oh, there is a little bit of activity. Okay. Oh, yeah, I zoomed out a little bit. I should have done that actually from the very beginning. So we'll just start again, zoomed out a little bit more, because you should be able to see that there's some activity on some of these lines. Nothing going to the cartridge port. I'm on pin 12 there, 13. It's also kind of nothing. Sometimes it helps just to kind of turn it on and off. Okay, there was some selection, looked good. Okay, here we go on pin 15. Lots of activity, that looks normal. Remember, we're looking for it to not go high enough. So like if it only went from ground up to like 2 volts or like 1.5 volts, that's where we potentially have a problem. Okay, we're at pin 16, that's the kernel ROM. Then we have basic ROM. I know you might think this is problematic. You see how there's like a little bit of noise there, but I think that's just inductive noise from some of the other outputs because the kernel ROM right next to it had lots of activity happening on it. And we're really looking for this to not be, well, to be lower than like the 3 point whatever volts that sat there, which is fine. And then this one here, 3 point something volts. This is, which ROM is this? Which pin is this? We are looking at the CAS RAM line, I think. Yeah, that's pin 18, CAS RAM. So that looks fine. So yeah, turning on the computer, I mean, the CPU is doing something. I'm actually wondering if the computer is suddenly working. Okay, we're getting a brown screen. That's interesting. Oh, look at that. Sorry about the flashing. That's a cool effect, isn't it? I like it. Okay, here's something interesting. I just pushed on the kernel chip and it changed dramatically. See that? So we could just have bad connection in this socket for the kernel. So why don't we deoxit that socket, right? Well, if I pull this out, I assume we're just going to get nothing. Okay, we got a purple screen. Commodore used really low quality sockets, so it does behoove you to just take everything out of the sockets that are in sockets and then put them back in. And if you have some contact cleaner, deoxit, that kind of thing, you know, do that. All right, we're sort of back to where we were. That was just weird. Still could be a bad socket, but it was just funny how when I touched that chip, it changed dramatically. Huh. Rainbow effects, everyone. Rainbow effects. I mean, it's kind of pretty, actually, the effect. It's very random what we get, too. Very interesting. The problem, the thing where I touched the chip and it changed, that kind of went away. All right, so this is interesting. I just heard some static on the VIC chip or SID chip. There's some noise on it as well. I'm wondering if that chip that selects the VIC and the SID is somehow bad. Remember the one I was talking about on the schematics? Let's investigate. Because what I'm talking about is I think if this chip were somehow bad, I mean, this takes the IO line that comes from the actual PLA. We saw that was fine. and it takes these two address lines and then generates these select lines for the color RAM, the SID, and the VIC. Well, we got to look to see if those are okay, because we're getting weird sound, we're getting weird video that just sort of screams that those are being selected like at strange times and whatnot. And I don't remember if I saw the IO line actually do anything. That's the enable line. This chip shouldn't even do anything unless that IO line is toggling. So we got to find this chip. U15, by the way, also generates these chip selects for the CIA chips. Here it is, U15. It's this chip right here. So I'm going to start by looking at pin 1. This is the IO line. This is what comes from the actual PLA chip. Wait, what? Am I on the wrong chip here? U15. That's not good. Did I miss something on the PLA? Because that is screaming that that is a bad output on the PLA. Pin 12 right there. I thought I looked at that. Now, this should be the same pin right there. Oh, how did I miss that? Oh, people must have been screaming at the screen. That's the bad line right there. That is the problem that's keeping this computer from working. Oh, what was I doing when I checked the PLA? So yeah, starting at pin 12 is right there, IO line, but I would start it at pin 10. Okay, so starting at pin 10 again, looks good. 11, looks good. 12, not good. That is our problem right there. Right, so what's happening here is pin 12 is stuck low. So even though we saw it was toggling, but it was toggling between like 0 or, near 0 and like 1.2 volts or whatever. So essentially that line was always selected, was always turned on. Now, when you go over to this chip, what was happening is it was enabling the VIC and the SID and the color chips when they shouldn't be. So these are going to toggle based on the address lines here, but this enable line should only be turned on when those chips are actually being accessed by the CPU. But this chip thought that they're always turned on, so it's just going to enable these lines all the time, which is why when I kept power cycling, we get like random flashing and colors and all that stuff. And that's just really because SID, VIC, and the color RAM were all being turned on when they shouldn't be. So when the CPU was busy like reading from the ROMs or reading from the RAM, the SID and the VIC think like, oh, you're talking to me as well. So they were like talking on the bus and being written to. And that's why we're just getting all that random crap. So 100% without a doubt, one of the faults on this machine, it might be the only fault, but one of the faults that's keeping this from working right away is that line on this PLA. So we got to pull the PLA out and put another one in place of it. And then we can kind of go from there and see if there are any other faults on this machine. I don't know why I missed that pin when I was initially testing, looking for those signals. I mean, that was literally what I was saying that you should be looking for. And I must have just skipped over that pin. And I thought I tested twice and I still didn't even see it. So I just want to show that even I make mistakes like that. And that means now I'm going to have to remove these bottom cover, which is super annoying. Let me get this off of here. To get the shield off, just heat up the little joint here and using the same pick I was using earlier to get the chips out. You just get under the little tab and get it off there. There's our C64. Let's just see if there's any rework that's been done on this. Nothing obvious. We had like those TTL logic chips that were in sockets. That doesn't appear to be something that was done after the fact. It's very common for Commodore to have put random things in sockets because they were out of stock of those chips when they were building these. So they would just populate sockets, put the boards aside, and then they would repopulate those chips, the missing chips later, and finish the computer, put it in a case and stuff like that. So that's why you just like get random things in sockets sometimes. It's just the way it was done. Okay, well, at this point, there's really nothing to do other than remove the PLA. That's what has to happen. And of course, desoldering stuff is kind of annoying. I'm going to be using my Hako 301 or FR 301, and this is an expensive piece of kit. You can do this with something like braid and copious hot air. It's annoying, but it's possible. I have some videos on my channel about how I remove chips, and if you don't have something that's expensive like this, maybe you can find someone to help you take a chip out that you think is bad, or we know this chip is for sure bad. One thing you can do is use some kind of side cutters or flush cutters like these, and we'll cut the legs at the top of the chip, and then we can just remove the legs one by one, and you can use a soldering iron to do that. And then what you can do is you can use some braid to clean out the holes and stuff like that. And hot air helps as well. And hot air rework stations are very inexpensive. But yeah, like what you can do is just take the snips and just like cut the chip legs like that. Okay, this chip loose. Yep, it is. There it is. Came right out. Broken pin and all. Well, left the broken pin behind. That's the one I cut. But there it is. So, bad PLA. Let me cross it out. I didn't put the X of shame on it, but there it is. In goes a new socket. All right, there we go. New PLA socket is installed, and I cleaned the backside, so looks pretty good as well. For an easy and inexpensive way to replace these PLAs, you can get these little PCBs made, 906114-01. It takes two PAL 20V8s, or GAL chips that is. It's the GAL-PLA. You put some pin headers on there and you get two chips installed, and that perfectly replaces this. And it's 100% compatible, and you can make these for a handful of bucks. You just have to get your hand on these little PCBs or buy one of these completely manufactured or already made for you. I'll just borrow the PLA chip that was in the previous 64 we just worked on, since I never put the screws back on. And we'll see if this makes this computer work or if we have some other faults. Of course, one of the issues with these round hole sockets is getting chips into them can be a little bit of pain. People don't like them for that reason, but I kind of prefer them. Only because if you take a chip like this that's been desoldered, it can sometimes be, well, if you put it into a regular socket like this type, it can rip up the sockets. I don't know, personal preference, you can buy either one, and they're both gonna work, although these cheap clone ones sometimes can cause issues, like they get worn out as well. Anyways, let's plug in the power and let's get this thing fired up, and let's see if we have a working system. What we can do is we can go and probe that pin 12 on here, and we'll see what we see now that this thing should be working. I like to do this where instead of just like seeing the output working, I want to see that we actually have the correct signal. So I'm on pin 12. There we go. It's at 4.3 volts. And now if we go to U15 right here, and I'm on pin 1, that is the IO input. Instead of being down at like 1 point whatever volts, it is not like that. So I have a feeling the system is actually working now. And let's look at pin 15 on the VIC chip. That's the Luma output. And there it is, looking good. Let's just try to get this to trigger properly. What's interesting is this one doesn't have as much of that white line that the other one has. Interesting. But anyways, I can see that it's working. And exactly like I explained before, we have the border regions. That's the darker color. And then we occasionally have static, and that is the actual text that is displayed on the screen. So this one appears to be fixed. And switching to the correct input, there it is. More jail bars on this design than on the other one. It's also very, very soft because the RF modulator design have to be modified to look a little more clear. But let's just power cycle this. It should be working fine. Yep, looking freaking perfect. While I'm here, let's modify the RF modulator just to make it look less crappy and a little bit more sharp. It's always a bit of a pain to have it off, but there it is. Okay, I always have to look up which components I need to cut. I can never remember exactly what it is. I think it's like one or both of these disc capacitors or something around this section right here. And then I think it might be this inductor just to like jump over it with a piece of wire, and that will remove some of the color fringing that's going on. Let me go look up exactly which two components I got to cut. Yes, I just checked. We have to cut out these two disc capacitors and then jump over this inductor. First, let's take a look at something or some like video output just to see what the sharpness looks like. And I always like to use my Easy Flash 3 for that. That looks really soft, but we are not hooked up through Luma Chroma. So let's switch over to that, because this will make a bigger difference. So I already have the cable switched over, and I got to switch to this right here. Okay, there we go. So things are looking pretty soft. Specifically look around the club games and game collection between the L's there. When I remove those two capacitors, it's going to sharpen it up quite a bit. Okay, so I'm going to use these little cutters here, and we just need to cut these two caps here. Just cut one side of them so they are disconnected. So that's one, and the other one right here, like that. And right away, you could see by the word game collection, it is so much sharper already. But the issue with this inductor here that I don't like is if you look just to the left of the A, B, C, D, E, F, there's some extra color bleeding that's happening, and that'll go away if we jump over that inductor. So you don't need to actually remove that, you just need to jump over it, and I can just use a little offcut. I have a bunch in this little container right here, so I'm just gonna grab one. These are from, I don't know, resistor legs and things like that. So it's now connected on both sides. That means it's just bypassed, it's jumped out. If you look at that color bar that is just to the left of the letters, there's less bleed now. So those are the two mods I recommend doing. Now, unfortunately, this mod is only for this particular modulator. It has a part number, oops, sorry, that's pushing on the buttons there. Has a part number MD6VA3403. It's used on the NTSC consoles. I have no idea which components you would cut on the PAL version of this, and this mod's only for this revision of the board. If you open up your modulator, it looks exactly the same inside, then you can do this mod, but if it looks different, then sorry, it's a different mod. I made a video about this a while back where I kind of figured out what things would need to be cut to improve the video quality, and yeah, it's very easy on these NTSC consoles. So if we turn this on one more time, yeah, that looks so much sharper. It's unbelievable, the change. Now we'll go back to composite because I don't think the change is really dramatic or really anything at all if you're on composite video. Maybe that's sharper? I'm not sure really. I think that is a little bit sharper. It's hard to say. It possibly could make the jail bars worse, so just FYI. And I think on this other 64, the one we worked on a moment ago, I think this is different inside. Well, yeah, the part number is different. This is MD6VA3405. This one's a 3403, so I'm not sure this is actually compatible. Let's open this up and take a look, because I just can't remember, to be honest. Oh yeah, look at this one. Super simplified. I think a lot of that stuff, like those capacitors and things, are on the back side, so it's possible a mod like would be possible here, but it uses surface mount components, and these are a pain to take out. So I honestly wouldn't do the mod on anything except for the one, this 03 version that we just did it on. That's the one that needs it the most. If you do want to turn the RF into composite output, all you have to do is just cut the connection that's right here, because there's a little connection that goes down to the board. And one of these pins right here, I can't remember which, it's like that one maybe, or something like that, you have to look it up, is composite video, and you can just run a little jumper link or piece of wire from here to there, and then that will turn that into composite video. So if you don't feel like breaking out a cable all the time just to plug in a composite monitor, you can just repurpose that. That would of course mean you would never have RF again, but if you don't care about that, then yeah, that's perfectly good. All right, so this 64 seems to really be working well. Obviously this PLA is from the other machine, but it just would need a new PLA to make this thing work. What I haven't done is I'm just gonna quickly do the final diagnostics, and then we just need to make sure the SID works, because we haven't actually heard that do anything yet. Uh-oh, we have a bad SID on this machine. It's got bad channels. Oh, darn it. So we did not get away with a fully functional machine. It's these 83 computers, they're so sketchy. Like, it's MOS was just making bad stuff at this point. MOS got a lot better later when it came to Amiga stuff, for instance. It's just, everything in this 83 era was just junk, unfortunately. The worst thing here is that there can be SID failures as well that make it where even the test and the diagnostics sound fine. So you could have a machine you're buying and they play that recording for you. Like, oh, see, it's fine, but it's still not fine. You could still have issues with various filter modes and stuff like that inside the SID that cause issues. So you really need to hear some more complex music. If anything, ask them to play the Donkey Kong arcade intro, which is the 8-bit dance party music, because you probably heard that on my videos, if you want to be sure that the chip is actually working. The rest of the computer, as you saw, like, there were no errors, so that's good. So this thing does work. It's just the problem is, well, I'm gonna have to remove that SID, put it in a socket, and then whoever gets this computer next is gonna have to pop a new SID in there. This is not working. I don't get it. Kung Fu Flash is generally like very compatible with stuff. What happened? What did I do? The computer re-broke itself. What? Really? So it passed its diagnostics and then it decided to fail. You gotta be kidding me. Oh, now it's working? Well, that's not reassuring, is it? Not at all. What happened? I wonder if there's like a little... That's broken badly. Yeah, okay. Okay. So yes, without a doubt, this needs a new SID. Obviously, the computer functions. If you're not going to really listen to music and sound and stuff, it's going to be fine. And some of the channels are working there. So if the filters are screwed up, the SID is bad. And in case you think like, oh, there's a problem on the motherboard, that's not the case. The output of this pretty much comes directly out of the audio output. So the SID itself is definitely 100% bad on this computer. I'm wondering if the reason why it wasn't starting there was because I had little bits of solder balls and stuff all over the bench, and maybe something had happened. Let me bang this around a little bit and make sure that it still works. Yeah, it's fine now. Yeah, I kind of banged it around and just made sure everything was pushed down. Let's just bend the board while it's running. Oh. Well, how interesting is that? So we still have some kind of a fault on here, some kind of a physical thing. Really? Remember how when I was pushing on the ROM and it was changing it? I wonder what's going on here. Okay, well, these types of problems can be tricky. Let's see if it does it now. Yep. Now this could just be a bad cartridge connector. Let's see if it... Oh no, the computer's not even starting now, so we're back with that fault. Oh boy. Well, this, well, I thought I was going to be done with this video. Clearly not. Okay, so that's the diagnostic cartridge. Let's twist this. Where is this fault? So I could push on things. All right, so I don't think it's the kernel ROM. I doubt it's the VIC. It's unlikely to be that. It could be one of these multiplexers here. I'm just pushing on stuff, trying to hope for like a change of some kind. I mean, the PLA? Did I forget to solder a pin on the bottom? It seems to be changing a little bit with the PLA. Let me push down on it, power cycle the computer. Aha. Let me just jiggle the chip in here. Just carefully hold the motherboard down. Yep, I think the socket might be bad. Maybe that have a bad solder joint on the bottom. Yeah, it's pretty flaky right there. So I think it's the PLA there. I don't think it's the chip itself, because that was in the other machine and it was okay in there. Just when I was saying like, oh, these sockets are good, I really don't have problems with them. It's not working. It's in there really, really firmly. It's like not like it's loose. Yeah, and this chip itself doesn't have the offcuts. Like the pins are full length and everything, and they're not dirty or anything. Well, I don't know. Let's try putting some deoxit. Oh, actually, first let's check the bottom side. Make sure I didn't forget to solder something. I mean, it's possible I have a bad connection on one of these pins. I don't see any bridges. Didn't really check for that, but look at that. There's a little piece of solder right there. I don't think that was actually causing a problem, though. I'm just going to spend a moment to reflow these joints here. Everything seemed fine on the bottom, but let's see if that changed anything. It's possible I have a bad connection on the top side under the socket. I didn't really inspect, I have to admit, when I took the socket off. Everything looked fine. The chip came out super easily. I used my fingers to remove it. So it's not like I pried it out of there, which could have ripped a trace. But at least I know it's pretty easy to reproduce. Oh, obviously, it's still bad. Dear, oh dear. Now I just lifted the chip out of the socket a little bit, and let's see if that made a difference. Look, now it's working. That kind of implies that there's a problem in the socket itself. It's like just a bad connection on one of the pins. So if I push this down back in there again, let's see if it's now fussy again. Yeah, look, immediately it crashed. I lifted out the top side towards the IEC connector. Right away it's bad, but let's lift out the bottom side again. I just lifted out a little bit, still in the socket, obviously. And look, it works. Twist the board. Oh, well, it still crashed there. Okay, well, I guess I have to eat my words that these sockets are good, because this one's clearly not. Let's put some deoxit into the socket. Brand new socket, shouldn't be needed. but it's kind of junk. I mean, maybe, I guess there's some oxidation on this chip as well. Okay, there we go. It's in there. Black screen. Oh, you gotta be kidding me. It's just such junk. Such junk. Oh, yeah. This is like the socket's bad, or there's like a bad trace underneath it. What kind of crap is this? This sucks. This really sucks. This is not reliable. Yeah, no, clearly. That's, oh no, this is terrible. Okay, I guess I'm removing this socket and we'll put a different one in. Gosh, that's so annoying. I guess I really need to stop using these cheap AliExpress sockets. Okay, it's gonna be a jump cut this time. Nothing like doing your work twice. So I removed that crappy socket and I just installed a normal, wipe socket, not the round hole type. And I did remove the bad SID and I put the one from the other board in here just because we know that one works. Let's see if this machine is now fixed and I can like bend this board without it crashing. I also double checked with the loop here to check that there was no bad traces on the top side on both of these chips, and there were not. Everything looked perfect. Interestingly enough, when I desoldered the SID and this socket, both of them kind of fell out of the board. It's so weird how some boards were really easy to get the chips out of and other ones can be really difficult. And I don't quite get why there's a difference, but these boards were all made by different manufacturers for Commodore, and I guess some of them just have bigger holes than other ones. Okay, here we go. Make sure everything's in the right way around. Yes, SID is down here as opposed to up there. Here we go. Okay, it works. The black screen you get for a little while it's running the RAM check, that always freaks me out a little bit. Let's pop in the diagnostic cartridge and I'll bend this board. Come on, please, don't crash. Okay, good. It's fine. Wow. Yeah. This freaking socket was bad. Unbelievable. I mean, I believe it. It's from AliExpress, but very annoying at the same time. Cool. All right, keyboard is connected so we can hear some music. Here it is. Is it working? It's working. It's working. And it was a good test. Whoops. Because obviously it sounded absolutely horrible when we heard it on the other SID. So that was a great test to tell us that, yeah, it was absolutely bad. Now we can take a look at some other SIDs. I have a SID player on my Kung Fu Flash here. Blah, blah, blah. Just go through all this. And 85 or 6581. And let's just try like syncopated here. Working well. Yeah, everything on here is gonna work fine. I can tell right now. Oh, that file, that one does not work. Ocean loader. All right, so this machine needs a new SID and a new PLA since both of those chips, which are sitting right here, are bad and had a bad socket that I put in. The last machine we worked on had that bad 7701. What I'm going to do is I will build up one of these MOS PLA replacements, and then whoever uses this machine next will have to replace a SID replacement. I don't have an excess of them, but you know, obviously the SIDKick, like I talked about, that's in my ZIF machine, that will be a good candidate to go in here. I think it's a pretty accurate match. I'm going to put these chips back into the other machine since those are what came in it originally. What I like to do with these excess 64s that I have is what I call catch and release. Because I already have enough 64s, I actually give these away to local people here in the Portland community. People often ask if I sell these machines. I do not. They were given to me in the first place, so I don't sell them since I like to pay it forward to other people. And the local folks in the community here don't have access to, free machines like I do all the time. So I like to pass it on to them. And obviously, like I said, something like this is going to need, well, I'll put the replacement PLA in there, but it's going to need the replacement SID. And of course, this will need a power supply and like a video cable. So there's some extra stuff that's going to be required to make this work. But at least I validated that functionally the rest of this thing is ready to go. And that way, whoever gets this next won't have to do any of the troubleshooting. And then we have our local meetups here in Portland, and I can just you know, hand it off to the person that's going to be getting it, because I don't really have time for logistics and packing and shipping and all that stuff that would kind of come with that if I were to sell these. All right, so with this 64, what did I learn? Well, I learned that even when checking the PLA outputs, you got to be careful not to skip any, which I did, which led me down a slight detour, just trying to figure out why we're getting that random cool garbage. That was happening because the LS139 that turns on the SID, the color RAM, and the VIC was being turned on all the time because the PLA had failed. That output had failed. That was the pin 12. And somehow when I was going through all the pins, I somehow missed it, or I didn't see it, and people would be screaming at their screen. I'll find out when I go to edit the footage. Otherwise, relatively easy to fix, except for the fact that I put one of these cheap AliExpress sockets in, and that bit me in the behind. So I really need to probably stop using these. Unfortunately, I have tons of them. I mean, I don't know. It's actually the first time I've ever had one that was so flaky right off the bat. I've had them where they kind of get to the point where they don't hold on to the chips very easily, and you can like take them out with your fingers. That one was gripping it really tightly, but obviously one of the pins was not. So yeah, some replacements. I found a tube of replacement sockets. I probably need to start buying the dual wipe sockets instead and just stick with those. So that was two very easy to fix Commodore 64s, but the goal of these videos is to show you that, well, there are common faults with these bread bins, and with something that's inexpensive like an oscilloscope like this, you can generally get to the bottom of exactly what's going on. And then if you have the RF modulator in these older motherboards, like the ones from '83, you can do that mod to improve the sharpness. But yeah, you won't be able to do it on these later ones because that RF modulator is totally different. So I hope you like this kind of interlude of a 64 video. It's like coming home. I used to do a lot of 64 repairs, but I don't really have that many, although I still have 2 more 64s down there that I'll need to get to. We can hope that when I get to those repairs, that maybe those will have faults that are more difficult to fix than these 2 pretty simple ones. But you never know with a 64. It's like a box of chocolates. If it's a mixed box of chocolates, you just don't know what you're going to get when you take one, because you're going to get a gross one, you're going to get a good one, you know, easy one, hard one. I don't know. It's all over the place. And yeah, that's going to be that. Thanks for everyone who came to say hi at VCF. I'm doing this video because I'm so behind on doing the whole VCF thing that I needed something that was quick and easy. And I knew 64 repairs are always something that are quick and easy to do. And that's what I've done here. And if you like this video, thumbs up would be appreciated. But if you didn't, you know exactly what to do. I'm sure people will say, like, I always do 64 repair videos. So I think it's been a while since I've done any. So can't really complain about too many 64 repairs. And I have so much stuff to work on in the basement, but it's all about getting stuff in order. And I have other projects that I have kind of midway through, but I wouldn't be ready in time to release a video for the weekend. So that's what this one is. And I guess that's going to be that. So thanks to my subscribers. Thanks to my supporters. Subscribe to all the usual YouTube junk, and stay healthy, stay safe, and I'll see you next time. Bye.